All right, so our next speaker is joining us from Fontys University. He will be talking about autonomous driving and methods to mitigate adversarial conditions. Please welcome Kirill Smirnov.
Okay. Thank you everyone for coming here. I am quite a beginner in federated machine learning. I only started a year ago, and this is basically the project I have been working for my graduation, and I would like to discuss a bit about it. So the title is Federated Learning and Edge Devices and Strengthening Data Privacy and Security, and the whole project has been sponsored by the Interreg and the ART-IE project. So what are edge devices? I think all of you know by now. It's basically similar to IoT devices. It's the devices on the edge of a network, and it can range from cars, sensors, watches, and everything you can think of. And what is federated machine learning? Well, everybody here is aware of it. It allows us to have a decentralized approach in training models across multiple devices. And of course, the benefits are privacy, data transfer bandwidth usage, and enables collaboration between those many devices. So for the research domain, there were quite a few options, be it medical, but the focus was on autonomous vehicles. And why autonomous vehicles? Well, because they have a lot of benefits, such as real-time data They basically obtain data while driving. They improve the model, and they have very diverse and distributed data because the different vehicles are located in different locations, different time of day, and so forth. So what constraints does federated machine learning have? Well, the initial constraint is the resource. So some CPUs are just unable to process data quickly enough. Then data diversity and distribution. So non-IoT data is quite popular in vehicle settings, and it's caused by factors by weather and traffic patterns, quantity of data available, and so forth. And of course, the highlight is a security vulnerability. So adversarial attacks such as data poisoning, as some have previously mentioned, degrade global model performance. So for my project, I decided to use clustering, weights-based clustering and accuracy-based clustering. I did a bit of switching in the project, and it would basically group clients with similar models to optimize the training efficiency. So for my experiment, I had 4 client clusters with an adversarial attacker, which would poison a different amount of them, and then they would aggregate the model and send it back. So in the latest version of my project, the clustering has been done based on the accuracy. So only one thing to measure, which is very easy. And the clustering itself has been done using k-means. So first we had the accuracy scores for the round, and then they would get clustered. So for this project, Flower Framework played the biggest role, so I could easily customize the clients themselves and the strategy to cluster them. For the model, I used the MobileNet v3. It is pretty lightweight and efficient for edge devices. And for the dataset, I chose to do something out of the ordinary. And it's a dataset from Kaggle with over 8,000 images. They are a bit blurry because they're only 480 by 300 pixels with 5 labels each, well, with 5 labels total. And they were recorded from the dashcam of the vehicle. So I experimented with multiple scenarios, such as the baseline experiment without any data poisoning conducted, and effective number of poisoned clients with a fixed poisoning percentage, and so on and so forth. And in total, 24 tests have been conducted. So from the results of my experiments, the base model, basically without the clustering, so I still had a federated machine learning setup, was 60% accuracy, and with clustering, it jumped to 72% accuracy. So on average, the difference was, well, nearly 18%, and the best was 18%. So on the bottom left graph, you can see that it was tests 1 and 2, basically the baseline, with and without clustering, but with no data poisoning, and they performed quite similarly. Then as the number of poisoned clients increased, it basically improved the clustering. And when I introduced non-ID data and data poisoning at the same time, the improvements, well, were way more noticeable. So for some of my conclusions that I have found from my experiment is that dynamic clustering is able to successfully mitigate data poisoning, depending on the number of clients. MobileNet v3 is a lightweight model enough to train all of the clients. And the approach, I first also wanted to find out if it's feasible to do the training on the autonomous vehicles, and it consumed about 15 to 20% of the CPU. So that was still making it possible to train while utilizing it. So for the future of this project, at least my recommendations were refining the clustering techniques by enhancing the adaptability, by dynamically adjusting the number of clusters, because mine was hard set at 4. Then improved model selection. It is because each cluster provides a different model, aggregating all of them, even with the poisoned ones, is not the best idea. So you want to specifically select which clusters are contributing. And then expand the applications. Test the methodology in diverse real-world scenarios to improve scalability and robustness across edge environments. Because currently it has been only tested on driving data sets and everything such as that. So thank you everybody for listening. If you are interested in the code that I wrote, please check it out. It's currently on GitHub and public. I will be uploading the research paper to it soon after today.
All right, thank you so much.
Yes, we have a question.
Perfect.
Yeah, thank you again for this nice job, and welcome to this Federated Learning Award. No? So I wanted to know if you managed to somehow evaluate the quality of the cluster that you were creating or not, or if you thought about doing it later. The quality of the cluster.
The quality of the cluster. I haven't measured individually quality of the clusters themselves, but more of the performance of the clients. But to calculate the performance of the cluster, you can maybe probably just combine the total and have a specific formula for that.
Yeah, or for example, I was thinking about the silhouette score, something like that, because you have used k-means, so probably you can see how good it is based on the silhouette score. I don't know, something that
yeah,
out
probably.
of okay.
It's just I had quite limited of time, about 4 months to complete this project, so there's definitely a lot to improve.
Okay, thank you.
Thank you for your question. Anyone else has anything to say?
We have a question here.
There it is.
And also, if you're joining us on the live stream, feel free to send the questions through Slack. We'll also be watching out for those. Go ahead.
Hello, thank you so much. Hello, thank you so much for the talk. I was wondering, you're clustering based on the performance, right?
Yes.
So, and then because you're also using it on edge devices, have you encountered a problem that you're over estimating some of the edge devices because some edge devices may just have limited capability, which yields a bad performance, and then you accidentally thought that they are poison models?
So you mean I might have accidentally thought that they were poison models because they're poorly performing?
Yeah.
Well, in my simulation, basically, I artificially made the poisoning. So we have a normal data set, then I do some label flipping, and it goes from 10% of the clients poisoned or 10% of the data poisoned to up to 100 for both of them.
I see. Thank you.
So you can adjust it. I also have a user interface in the code if anyone is curious, where you can adjust the number of clients poisoned, the number of clients used, and the poisoning percentage.
Perfect, thank you.
All right. Thanks a lot, Kirill.
Thank you for your time.